Alright, so this is a quick video on how I like to perform a gas furnace maintenance. So I've got my temperature. It's basically just a K-type probe reading my temperature, min-max, 123 so far at the supply. Then I'm going to go ahead and drill a test port about 1 foot up from the actual discharge of the inducer. That bit is getting dull, but we've got our combustion analyzer, Testo, and she's ready and warmed up. Always like to calibrate these outside when you're doing your ambient CO. Or even, the thing that's so messed up about it is it wants this combustion air temperature, so whatever. I'm not gonna. So basically, go ahead and install that cone. And what that's doing is it's gonna help you to be able to tighten this probe down in there. Okay. Now let's start. Now with this being a carrier, I'm pretty sure it's gonna have high carbon monoxide, just because that's what they do. Yeah, there you go. See what I'm saying? Like, that's totally off the charts, man. Totally unnecessary. Let's check out our undiluted as well. Wow. Uh-oh. Take it out. Stop it. 3,000 parts per million. See? So that's vile. With this furnace, that it needs to be rectified. You can't run a furnace like this. I'm going to check and see if there's any CO in the actual flue pipe, in the supply air. That's going to be interesting. So as you can see, I stopped it. I stopped it pretty much midway, but we have got 3,000 parts per million undiluted CO, 1,500 parts. Let's see what, I just want to look and see what everything else. O2 is 10%. I didn't leave it in long enough to get all of our metrics. I want to see what our excess air and everything is. 95, nothing too crazy. So what I'm going to do, I'm no longer going to be running in combustion mode. I'm going to just check the static pressure, the draft pressure essentially, and make sure there's no kind of restrictions or anything crazy going on, but there's something weird going on here. That draft pressure looks good. I usually want about 3/400ths of an inch of maybe 2 to 300ths of an inch of static. So there's nothing wrong there. So with this furnace, I'd say it's probably an impingement issue. Yeah, as you can see, the flames. As you can see, the flames are essentially really hitting up at the top of that. The top of the inlets there. Big gap down there. These carriers, they're insane, man. Let's just check and see if we got any CO. 127 degrees coming out. Let's see if we've got any CO going on in this here. Let's start it. Let this thing calm down. You gotta flush it out first. Get it back zero. So yeah, I'm gonna quickly check my amp drawer on the inducer of the blower. So you see we've got about 1.4, 1.35. So this will tell you 1.4 is your run load amps. Then we're going to get our blower 6.34. So what I'm going to do is go ahead, if I want to get the blower amps only, I'm going to take the There's the inducer line in. I'm going to tie that in with a blower and check that out. 5.3. I took it down. So it's going to be about 5 amps for your blower, because you got about 0.3, 0.4 for your low voltage, the transformer, the board, thermostat. So, okay, so nothing, no CO in your supply. That's cool. I figured it wouldn't be any. Let's see. Now what I'm going to do is quickly check static pressures. That's not going to fit in there. So what I like to do, I've got my hose, slides right along that, and then I've got a rig here to check. I can check anything with this. I can do gas. I can do, that's just a little ball inflating tip. So I'll just use my combustion analyzer on draft pressure mode. This actually is a lot more sensitive manometer than even the field piece manometer, so I do like using this to check static pressure. Don't get me wrong, it does bounce around a whole lot more, so we're just going to go ahead and pop that in there. 0.4 on our supply. Okay. And then for our return, we'll just pop this in here. Let's just pop it in. I like to check the return like in the actual blower cabinet. Now I'm accounting for even the static pressure on the plenum itself. 0.36. 0.4 plus 0.36. That's going to give us our total. Okay, so now I'm going to go ahead and check my flame sensor, DC microamps, with the field piece. And I like to go ahead and, if possible, if we get enough of a delay, I like to try to do these on the fly. So what I do, and if I got enough space, my word, usually they give you a little bit more leeway than this. But I like to go ahead and put that clamp on there, take off the sleeve for this, and then we should be able to just, that's hot. Should be able to just kind of, alright, so turned off. I wasn't able to get it on the fly, but you know what, while that's doing that, I'm going to go ahead and get my things in to check gas pressure. Just love this Klein Socket and mini socket, and I just set it up to where I'm using the 5/16 bit holder from an 11-1. I can put any size bit in there. Also use these to close down refrigerant valves, service valves, and things like that. So works as a hex head as well. So let's go ahead and pop that in there like such. I'm going to check my manifold pressure. I'm really curious. We got our field piece job link probe here, and once again, basketball inflator with a magnet. Got this magnet off like an old Sonicare toothbrush. And then we've got this here port where I can use for gas valves, the standard gas valves. It's got the small nipple. Use that. And then for the threaded, boink, like such. What I think I love about field piece, they think everything through. Check this out. See? So when you're threading this in, the hose tends to spin. So look, you just spin the hose with it. And that keeps it from you making the hose bind all over the place. Okay, go ahead and turn that on. Make sure you zero. It's already pretty good looking, but always keep it zeroed out. And it's really important that you don't just stop and give up and then just go run to the customer telling, oh, we found high CO, you need to get rid of the furnace. You want to try to pinpoint what caused this issue, what is creating the high CO, if possible. That way you can give them a proper, assessment. So I'm checking gas pressures. I mean, honestly, I don't think it's going to be in the gas pressure. I think 90% of the issue is going to be in this manifold here. It's probably cocked. I don't think it's a coincidence that the turn direction of the gas piping is going to be the same direction that the manifold is tilting upward. So essentially, more than likely, they just probably turned it out of whack. We're going to check our gas pressures out here. So we've got 4 microamps, which is good on our flame sensor. Gas pressure 3.7, which is kind of high, but it's not to the point where it's going to affect it. I'm going to adjust that. It should be around 3.5. Let's see what happens when this fan. Oh, look at that. The fan turning on definitely did affect the flame. Definitely it did. Now it's not turning orangey and things like that, but I saw this here burner got a little bit more wonky. So I'm going to go ahead and turn that off. I'm going to watch that one more time, just so I know I'm not going crazy. Alright, so it's about to start up. So I'm going to go ahead and try to pull this blower and see if I can inspect and, find any issues. 9 times out of 10 you're not going to see anything, but it's worth a shot, right? 3,000 parts per million. It's pretty significant. So I've given this ample time to cool off down here, so we should be good. I'm just going to go ahead and just lay down here on my back, I guess, and see what I can see. Give us a light. Okay. That's what we expected, and we're not seeing anything. Nope. Huh. What's that? Yeah, I'm not seeing anything, guys. Definitely not seeing any holes or signs of holes, so alright, so the heat exchanger looked fine visually. I'm gonna say, oh wow, look at that. So look at that flame. Huh. Let me clean up a bit. Just clean it up. Here. The flame started off pretty dirty. One thing I noticed though, it looks to me like maybe this gas line might have a lot of weight on it. So look what happens if I pull this up. Look at how that whole, look at that. Look how easy it is to maneuver that. So what I'm going to try to do is find something. Maybe this door. I think over time the weight of this line and just this whole side just started to sag, and I think this whole burner assembly is just cocked this way a bit. So we got 2,000 parts. I'm just gonna lift up on this, see what happens. No, it's still flying, it's still going up. Nope. Nothing. One more assessment. Yes. I'm pretty much not sure what's going on with this thing, but if you look here, see how this got about a half-inch gap there, and then on this side, not really a gap. So maybe in actuality, it's not able to go down anymore because this is hard. But maybe it needs to be pushed down this way, but it's not able to. I don't know, man. These carriers, man, they're a joke. So I'm gonna try to go ahead. The manifold connects back here at the back of the gas valve. So what I'm gonna try to do is I'm gonna try to twist this gas valve like such by literally just pulling up on this here gas line, and I'm gonna see if I can then push it down, push this whole burner assembly down a little bit and see what happens with it. So we're just gonna pull up here, make sure you hold it so it spins only at the gas valve. I'm just gonna pull up on it. There's here. Now we got enough of a gap here to where I can actually see here. I can push down here in the manifold. So yeah, the gap is closing in. When I push down, I'm gonna try to see if I can push down so that way this gap is the same on each side. Let's go ahead and start up. Now what I'm going to try to do is kind of turn this gas valve. I'm going to try to rotate it to where it tilts this way a little bit, tilts down. Let's see what we get out of that. Hold on one second. So we're just going to lock it in, see if we can get any kind of turn out of this. Okay, I see it turning. Oh yeah, it's tilting. The gas valve itself isn't turning, but that's exactly it, really. Matter of fact, okay, so as you can see, you see the rotation here. When I rotate the gas valve, you can see, and I went ahead and took one screw out, that one screw here, it's out, so you can see it lifting up off of that. But look at that amount of rotation that the burners are giving us. Let's turn it. And I went ahead and loosened this as well, this union, so you can see how it's turning. I'm just going to get that in the place that I want it. Hold it there. And then I'm going to go ahead and tighten this up. Let's see what that does. Okay, so I went in and tightened up the union here. I know it's all out of whack, but I'm going to get that right. Make sure I check for leaks again as well, because I've been messing with stuff. I don't know. Huh. We'll see how this works. Alright, so we got that up. We're just going to pop this probe in here, hit start, see what we get. Alright, okay, start. And I went ahead and put a spacer in between here for now, just to, Let's just see. CO's climbing pretty well. Oh yeah, same game. Let's see what our undiluted's at. 800. A whole lot better. Just skip this wrench. I'm going to go ahead and try to adjust this in real time, because it's a whole heck of a lot better than it was, as you can see. But try to adjust this in real time. So we're torquing it. Nope, no go. No, it's still flying on us. 3,000 parts per million. Look at that. Yeah, it's no good. 4,000. Huh. Yep, so there's no real resolution for this, I don't think. Take the gas pressure down a bit. Okay, I didn't catch it, but I went ahead and adjust the gas pressure. And I'm basically still holding this. And as you can see, we're rocking now. We're getting down. 1,100 parts. That's still high, but it's gonna drop. It's gonna get there. That's so exciting. So we basically got this thing. I think we're gonna get it in spec, man. Just gotta figure out how to keep this with the amount of gappage we need. As you can see, it's no longer impinging. Still not balanced, but it's a lot better than it was. Okay, I'll let it go. Took it off, no longer holding it with 800 parts per million. This is cool. Look at that. Uh-oh. I gotta still hold it. It's starting to shoot back up. So I gotta get this in position. Hold that in place for it to keep coming down. That's getting it. Adjust the gas valve, gas pressure a bit more. I didn't even bother looking at it. I'm gonna pull it. I'm gonna take the put my manometer to it here shortly, but I'm just kind of trying to get it. Carbon monoxide levels in the right place. Let's see what our excess air is looking like. 93. It was about 45, 50. 93 is not terrible. Yeah, I think that should be. We're getting within respectable, just desirable ranges. If we can get it to below 300 parts per million, I'll be satisfied. And this is just temporary. I've got this little, it's basically a temporary gap to where it's actually keeping that gas valve turned. So I think that's the only thing we can do to resolve this, guys. It's working. It came down from 6,000 parts to 400, so. Alright, so we're going to have to go up on our manifold pressure. We went a little low. It's 2.8, about 2.9 inches of water column. Another thing I'm going to try to do real quick is clean these burners and the orifices as well. Let's go ahead and pop the other screw. orifice up in here. Gotta disconnect these disconnect the rollouts. Just want to go ahead and inspect these things once and for all. The burners look good to me. So we're going to just let that sit there. Everything in there looks good. Yeah. All those look good. Now I'm just going to quickly check these orifices. So yeah, I'm just going to use my tire inflator tip. Just make sure those are nice and clean. Don't see any junk or anything, but whatever. Oh wait, oh yeah, it's clean. Okay. Clean these burners. Seem to be doing okay. I don't really need it, to be honest with you. Okay, so I just started her back up, and we got this 150 undiluted. $80 CO 160. I'm gonna go ahead and turn that gas pressure back up a bit. Right now we've got it down to 2 point. Still creeping up on us though, 220. And I've got to put the gas pressure back up. I'm going to run it at about 3.2 inches of water column. Okay, that banged us. That got us way back up into the red. So what I'm going to do, I'm going to try to lift up on this. I took these bottom screws out. I'm just going to lift up on the whole manifold. Yeah, that gas pressure is doing us in. It's back up to 1,000 parts per million. Dang it. Okay, so I'm running out of time. They've got to get out of here to take their kid to daycare. Alright guys, I'm just going to go ahead and call it. I mean, I tried messing with the gas valve, the manifold orientation, and turn the gas pressure down. So I'm just going to go ahead and call it, let the customer know, see what they want to do about it. Inspected the heat exchanger, all that, nothing. So yeah, sorry I wasn't able to come to resolve for you guys. Let me know if let me know what you think it could be, because I'm not sure, man. I'm kind of lost on this one. Probably something simple I'm just overlooking, but honestly it's yeah, it's a tough one. So let me know what you guys think, and see you on the next one. Thanks for watching.